Good afternoon, everyone. Welcome to TMS Tuesday, part 2 on compliance. We've got 33 countries attending today, so hopefully we should get some very, very interesting questions. Our panel is going to comprise of myself and Tony Coates, obviously Robert Shapton and Tony Smith, and hopefully Seward Ford will be joining us from the States a little later on. I'll do a quick recap on our part 1 webinar, and we discussed what compliance is and why we need it within the aviation industry and what the definition of compliance actually means. So if we just refresh ourselves on the act of compliance, it means the act of obeying a law, a rule, especially one that controls a particular industry or type of work. We looked at the main drivers for compliance and the factors which hinder our maintenance teams being able to achieve compliance. Some of the factors that we highlighted were as follows: high runway usage leading to reduced maintenance times. So as our routes increase, obviously the impact on our runways is significant because we need them more. Therefore, we have less time to carry out our maintenance tasks. This also highlighted other issues of staffing, shortage of qualified staff available due to budget restrictions to employ sufficient staff. In today's modern world, we tend to utilise our staff not just for AGL, but for every other service going. So we're looking at maintaining the actual airport infrastructure rather than just the runway. And this obviously has a massive impact on compliance. We also looked briefly at how we can speed up our maintenance procedures. And one item that we looked at was to relocate from landside to airside. So our parts are now airside, which obviously reduces the time that's needed to get through security and to actually get out to do the faults and the routine maintenance.
Okay, so interjecting very briefly into Kevin's presentation, if you remember, I said at the end of the last webinar that I would start off by giving a contentious statement. Realistically, as we've already seen from what Kevin has just identified in the slide, anything that affects the runway, the use of the runway, or the airside environment will have a direct cost effect on maintenance of the visual aids.
Let's now turn to, in the modern aviation world, how do we achieve compliance? Well, we have rules and regulations set at international and national levels. Internationally, we turn to ICAO and Annex 14. At a local level, we turn to the civil aviation authorities, which take information from ICAO and interpret and implement ICAO standards and recommended practices, shortened to SARPs. If your country is contracting state to the Chicago Convention, your CAA is required to comply with ICAO standards, which your CAA manages through the following methods: incorporating it into law, regulation and oversight, direct application and exemptions, and advisory material. So depending on what part of the world you're in, will impact on the standards for electrical safety and also how the guidance material is published. Let's have a little look then at Annex 14. So Annex 14, Volume 1, deals with aerodrome design and operations. The current edition is the 9th edition, which was published in July 2022. What is Annex 14? Well, it establishes the international standards and recommended practices for the design, operation and maintenance of aerodromes, airports and heliports. It is split into two quite distinct volumes. Volume 1 covers aerodrome design and operations, including runway specifications, obstacle limitation surfaces, visual aids, and rescue and firefighting. Volume 2 deals with heliports. So inside Appendix 14, it comprises of 10 chapters. Chapter 1 gives an overview of the document. Chapter 2 is the aerodrome data. Chapter 3, physical characteristics. Chapter 4, obstacle restriction and removal. Chapter 5, visual aids for navigation. Chapter 6, visual aids for denoting obstacles. Chapter 7, visual aids for denoting restricted areas. Chapter 8, electrical systems. Chapter 9, aerodrome operational service equipment and installation. And Chapter 10, aerodrome maintenance. A little further on in the presentation, we are going to focus in on some of the less obvious chapters which we have to comply with. Further appendices are also added to Annex 14, and these comprise of 5 appendices. Appendix 1, colours for aeronautical lighting, markings, signs and panels. Appendix 2, aeronautical ground lighting characteristics. Appendix 3, mandatory instruction, markings and information markings. Appendix 4, requirements concerning design and taxiing guidance signs. And Appendix 5, location of light on obstacles. Annex 14 is supported by various documents and manuals. Some of the documents in Annex 14 are very concise, but to understand some of the chapters, as I say, within Annex 14, reference needs to be made to the supporting ICAO documentation. So let's have a quick look at some of the documents that support Annex 14. Well, Aerodrome Design Manual, document 9157. Airport Planning Manual, document 9184. Airport Service Manual, document 9137. Let's have a look at the Aerodrome Design Manual, document 9157. This document comprises of 6 parts. As we're dealing with maintenance, I'm going to refer to part 5, which deals with electrical systems. Within this document, we will find all sorts of very valuable information, but we need to make sure that we are dealing with the correct volume edition. The current volume edition is the 2nd edition, which was produced in 2017. So within this document, you will find part 5 of the Aerodrome Design Manual provides specialist guidance on the design, installation and operation of electrical systems for aerodrome lighting and visual aids. It ensures compliance with Annex 14, Volume 1, Standards for Safe and Efficient Aviation Operations. Within this document, specifications for everything electrical can be found. This includes backup systems, changeover times, to troubleshooting faults. Let's now turn to the Airport Planning Manual, document 9184. This document comprises of 3 parts: master planning, land use and environmental management, guidance for consultant construction services. Our current document is the 3rd edition, which was produced in 2023. A master plan balances the respective demands and capacities of the many elements and ensures goals such as efficiency, adaptability, sustainability, and expandability and are met in order to meet the changes and the needs of an airport. Guidance on the following is provided to permit the phased development of the master plan. This will look at assessing the capacity of individual facilities, balancing demand and supply to reach the highest level of efficiency, and planning runway, taxiway and apron configurations, passenger buildings, ground transport links, and internal roads, car parks and cargo areas. We'll now turn to document 9137, which is the Airport Service Manual. This document comprises of 9 parts. As we are dealing with maintenance, I'm going to refer to part 9 of this document, which is Airport Maintenance Practices. Now, this is a very, very succinct document. What is the purpose of maintenance? If we were to look in this document, you will find in part 1.4, Purpose of Airport Maintenance, an airport being an important part of the aeronautical infrastructure has to meet high safety standards. The required level of safety can only be achieved by proper maintenance of all the elements composing of an airport. Maintenance includes measures to keep or restore the operational function, as well as measures to check and to evaluate the present function of an element. The basic components of maintenance are inspection, service and overhaul, and repair. So what is the purpose of a visual aid system? Part 9 defines this as to aid safe operation of aircraft. The basic purpose of visual aid systems is to aid in the safe operation of aircraft. Therefore, the highest standards of maintenance are required once a system has been installed. Its usefulness is dependent on its serviceability, which in turn depends upon the effectiveness of the maintenance work carried out. Annex 14, Chapter 1 defines a light to have failed when its light output falls below 50% of that specified for a new light. The causes of the loss in the light output can be containments outside and inside the light unit, and degradation of the lamp and optical system due to aging. The light can be and should be restored to its original condition by cleaning or replacing the lamp and for any parts which have become degraded. For this purpose, it is essential to establish a comprehensive routine maintenance system for servicing lights and other equipment, so that the installation complies with the specification requirements referenced in Annex 14, Chapter 9.
Okay, so giving Kevin a little break for a while, I'll take over with regard to airport maintenance practices. And realistically, who should carry out maintenance? A wonderful question to ask. And before we even get into anything that is in 9137 or Annex 14, what needs to be looked at, and it goes right back to one of the early slides that Kevin presented, was the local civil aviation authority will have looked at the requirements under Annex 14 and then looked at the requirements under local legislation and laws. And those are the first things that need to be applied. So if we're looking in the UK, it's the Electricity at Work regulations and the Health and Safety Act need to be applied to the people carrying out the maintenance before we even look at the requirements for AGL. But then Part 9 is very clear on what it says. And Part 9, it's 2.2.1, so it's Chapter 2, Paragraph 2, Section 1, personnel. The task of maintaining lighting aids should be entrusted only to reliable and skilled electricians who have had experience with high voltage, series circuits, and lighting. These individuals should be present or on call during the operating hours of the airport to correct any deficiencies that might develop. Training programs should be established to maintain the competence of maintenance personnel and to keep them abreast of new developments. So from that, possibly the most important thing to highlight is the requirement for reliable and skilled electricians. You say that's the actual extract from 9137 there. So we're looking at that. Now, the airport manager or the airport management side of things have a requirement to ensure that the maintenance team and maintenance personnel obviously not only receive the correct training, but that training is kept up to date. It is ongoing. and there are regular assessments carried out. But there is also a requirement that the persons carrying out the training are required to provide adequate proof that they are both skilled and experienced in the subject that they are training, and that they are skilled and experienced and qualified with regard to being instructors. Again, this is all within the ADRs, and it is all laid out. And any good training organization will happily be able to afford this information to any airport requesting it. Now we've established what maintenance is and who should carry it out, the interpretation of Annex 14 is much clearer. As you've already heard, Kevin started going through things. There's a lot of information that has to be absorbed and taken in, and also factored into any work environment for the maintenance side of things. Our visual aids are paramount for the safe operation of aircraft on an aerodrome and must be maintained by skilled electricians with high voltage, series circuits, and lighting experience. Very, very difficult to find somebody who has all that experience straight away, which again comes down to the requirements for the correct training to ensure that the shortfalls in inadequacies of knowledge are brought up to the correct standard. So what does this mean to an airport? Maintenance is not a nice to have. It's a mandatory requirement. It's a mandatory requirement under local legislation and regulations and laws for the safe operation of an airfield or any electrical system. It is required for compliance. Compliance is not an option. It's mandatory. It's a requirement. So everything all comes back to the fact that as from 18 months ago, visual aids was confirmed as being safety critical equipment. So therefore, it has to be maintained to the highest standard. And staff responsible for maintaining visual aids must be appropriately skilled, qualified, and trained. With that, I will open the floor to have a look at some of the questions that have come in during the period we've been talking.
First question we have is, what do the standards say about how an airport should be able to demonstrate or evidence that people have these required skills?
Individual airports are obviously governed by the local civil aviation authorities, and they have to maintain records which pertain to the training of their individual staff. And it is a legal requirement because your aerodrome operation license hinges on you having sufficient staff to maintain the operation of that airfield.
And so this is a requirement that you would expect the CAA or the ICAO indeed to be looking to seek evidence on their.
EASA and the CAA all put it down on legislation as well. So you have to maintain those records.
Just to be clear, the FAA comes under the Chicago Convention also.
They also have to keep records as well. So everyone has to have these records available for inspection.
So when you mentioned earlier, everyone that signed up, effectively, that's a global sign up. So
it's a global sign up,
everyone.
Yes.
Can you clarify the confusion? I've heard the term 2 years and 3 years.
What Robert's getting at on this, if I'm right, we've got the 3-year requirement whereby there has to be the ongoing update and requirement for retraining at the 3-year period. The 2-year period is the period now where training should commence. So if you look at the training lists that we produce, our first contact with delegates, apart from general contact, our first formal contact is after 2 years when we make contact with them with regard to written updates that have happened in that 2-year period. So the requirement is for a full, basically, update after 3 years, but there is also a secondary requirement for that update to commence at the 2-year period. So it's one of these things that between 2 and 3 years, you have an informal, formal training, and at 3 years, you have full formal training.
Mm-hmm. Okay, but this is all. This is additional to the national requirements for each national area.
If you take into requirements under the CAA, Civil Aviation Authority in the UK, as Kevin knows better than I do, you've got the requirements of the Health and Safety Act and the Electricity at Work regulations, which give you your basic requirements for people working on electrical systems. Without the requirements covered by that legislation, a person cannot work on the electrical system anyway. You then have the aeronautical ground lighting system, which requires further specialist knowledge in order to be worked upon. So, but you need that initial grounding of the local legislation, i.e. that in UK Health and Safety Act and Electricity at Work regulations.
Right. So in terms of the requirements for compliance and for airfield maintenance personnel who should carry out the maintenance, how's this evolved since the earlier editions of Annex 14 and the national regulations?
They've developed a long way, because when I first got into this whole issue of maintenance back in the late 1970s, when I found an appalling situation that where our CAA was licensing aerodromes on the basis of a flight test, which didn't do anything to address the actual requirements of the lighting. In other words, intensity, beam spread, and colour. The only thing it did in the flight test, during the flight test, was to look at the functionality of the brilliancy control and to see if overall there was a very ragged appearance. That was about the limit of what they were doing. And when I looked at the airports, one of the big problems was, of course, the maintenance people were often not just specifically airfield lighting. They were just so many of them just electrical engineers who perhaps had learned quite a lot by being at the airport for a long time. But there was no clear mandatory specification for them to be aviation lighting experts. As far as I could see, they were just covered by general legislation. And it was a very difficult place to start, because that's why the 50% was mentioned somewhere as the lights being compliant. I was responsible for suggesting that, because what I was getting was lighting that got 10-20% light output in the early measurements I made. And so, without having had the opportunity to do a very full assessment as to how we should meet this, and no equipment to do it, I suggested to the visual aids panel that at least we ought to put something in for the maintenance people. So I suggested 50%, very much as an interim until we could get all the stuff that's now in place. That 50% should be deleted, because it's causing confusion, because that was really aimed just at the maintenance people to say, come on, you've got to do something about proper cleaning and maintenance of your equipment. What we now have developed over the years, realizing that, yes, indeed, Annex 14 says shall, it's mandatory, it's an international agreement you've signed up to. Your CAA, in demanding to see records, they're fulfilling their function. If they don't do that, then they internationally are not enabling your country to be compliant with what your government has signed up to. So we mustn't forget that the CAAs and their inspection teams have an important part to play in this, to make sure that it does work. In fact, where we are now is so much better, because what we're looking at is saying, yes, the lighting should be bearing in mind what this says in Annex 14. These are minimum values. So if you like, in shorthand, if you took a runway centerline light of 5,000 candelas, that's the minimum it should be at any one time. So probably to achieve that, when you install it, you've probably got to have 125%, because there's going to be degradation. but you should never fall below that 100%. That may alarm some people who are hearing this, but that's what's actually required. And I'm pleased to say that there's so much more regulatory advice and, in fact, requirement in place now, because it was a very bad situation we were in 40 years ago. And the work that's done in the UK and one or two other countries to get proper measurement of equipments is vital to all of this.
Thank you, Tony. With a lot of these regulations, the question here is that we're addressing the current regulations, but are they, does the panel consider they're up to date, taking into account the current technology, both equipment and training?
I think it's fair to say that we will never ever be completely up to date with regulations because technology is moving so fast at the moment. Certainly within the electrical industry, there is a lot of changes taking place, especially around renewable energy, which is obviously impacting heavily on our airfields. So the regulations are never going to keep pace with technology and what's happening out there. If you take the UK just as one example, we have just undergone quite a significant change for the wiring regulations in the last 4 weeks. Okay, there is a 6-month grace period before all of this comes in, but even so, it will have an impact on some of our airside operations, especially where batteries are concerned for standby systems.
The other thing about it is, with regard to legislation, it actually takes longer for legislation to react and be put through than it does for new products to be developed and brought into the marketplace. Technology is developing faster than the market has ever had before. And so therefore, there is not a chance that regulations can keep up with them. The best we can do is try and keep as close as we can to them with regard to regulations. But the whole thing anyway with regard to regulations is that the basic regulatory requirements for working on electrical systems have to be adhered to by airports for their personnel before they can even talk about the use of those personnel for AGL purposes or aeronautical ground lighting purposes. So there is a basic requirement which comes under legislation and local regulations before it even gets onto the airport regulatory side.
Thank you, Tony. We've got another question here. As a prior airfield electrician and now designer, maintenance sometimes comes second to operations. I think we've all seen that. How should either a maintainer or designer stress the importance of maintenance compliance when it comes to balancing operations safety and the airport's financial duty?
Yeah, I actually put up a bit of an answer to this one. We brought up the subject, or Kevin brought up the subject on the last one with regard to the cost of maintenance, because as I said with the contentious statement today, realistically, anything that happens on an airport has a financial effect on the cost of maintenance, be it that you need additional personnel, additional equipment, updating of equipment or whatever. Because if you close down the amount of time you've still got the same amount of maintenance, if not more, to be carried out. Now, the whole thing about it is that to a certain extent, and you have the guys in the know, the maintenance department, the electrical department, some of the other, they know what needs to be done. To a certain extent, the senior management of airports are not fully aware of what is required with regard to compliance and also their responsibilities. And it is the airport manager's responsibility to accept the fact that maintenance is essential. It is essential both under regulatory requirements and under legal requirements. It is a legal requirement that electrical systems are maintained. And it's not a thing that you can think, okay, well, we can cut down the cost on maintenance. You cannot cut the cost on maintenance, because one of the things that to ensure good maintenance is that, if you look at the definition, is the cost should not be an implication when it comes to maintenance. If it is getting too high, then you replace. And this is where good money after bad comes in, as we always used to say. So the whole thing about it is, to a certain extent, there is an education requirement of airport management, senior management, with regard to what compliance is required on the airfield in order for the airport to be operational.
Thank you, Tony. One of the key things, something we've stressed in previous webinars, is actually presenting the figures. It's about the measurements that we take. And I think I've seen in the past airfield maintenance being, let's say, nervous about presenting poor results for their airfield maintenance, when even though that poor result is quite often attributable to the inability to be able to get airside access to provide that, to do the maintenance, or potentially to not having the tools or equipment needed to deliver a compliant visual aids or other aspects of the compliant airfield system. But I would say that it's very important that there should be a formal structure and process where compliance is demonstrated through KPIs with the necessary complementary analysis to explain why those results, in cases where they're non-compliant, why they're non-compliant. Bringing non-compliance to the attention of senior management, I would say, is absolutely essential. Otherwise, those performing the maintenance effectively are taking the full responsibility themselves, which I think is a very risky approach.
Well, my thought, what I was just thinking about as you were speaking, was the role of the equipment designers in all of this. Take the case of a car. If you design a car such that to get to a component you may need to maintain, you have to remove the engine to get to that component, that's not a very clever design. And I do feel, I don't think that this has ever really been addressed, whether there ought to be much more a challenge to the people who make the equipment, design the equipment, about properly demonstrating its efficiency. It can efficiently be maintained. I've never been part of any conversation where that's taken place, but I think, bearing in mind the difficulty of access to runways with the high capacity airports, then this is something that should at least be, have a conference about it, have a discussion about it, at least say to the lighting manufacturers, we have a problem here. Can you not redesign your equipment so it can be much more easily maintained?
A very good point, Tony. One of the keys to compliance is actually, like in everything, is actually getting it right in the beginning. And so, I've been sharing a lot of our experiences in light measurement with airports to try and avoid the problems on projects before they're even started. And these are problems. These problems can range from installation problems, in fact, and also to design issues, and something that's brought to mind by Tony's comment there. One of the biggest concerns I have is that and this is a plea to all lighting manufacturers, and that is, with LED technology, you no longer have the wasted heat of the incandescent lighting systems. But this wasted heat had some unexpected benefits for airfield lighting. Principally, it melts snow and ice, and it evaporates water because the lights, as you will all know, get extraordinarily hot, even in cold weather conditions and wet weather conditions. So one of the things we see with LEDs is pooling of water. We often see pooling of water on the lenses of the lights, which are often behind a reverse slope, so thus holding the water in front of the lens. And in those conditions of heavy precipitation, or even snow, but just normal precipitation, that those lenses become ineffective. The water diffracts the light away from the pilot's view, and in windy and I've tested in windy conditions where I've seen whole line of centerline lights that appear out when the wind is blowing across the runway, and it's quite shocking, really. And this is something that needs to be addressed in the design of lights, because in just the conditions you need compliant lighting, heavy, low visibility, which often comes with this precipitation, you get the effect of not being able to see the lights at all, or certainly very, very poorly. That's why people typically do not do photometric testing of lights in wet weather, because they know they're going to get bad results. Well, that's frankly not good enough. The lights need to be designed to work in those conditions and need to be compliant in those conditions. So, plea to you all out there involved in the design of airfield lighting. And of course, building on that same theme, that precipitation that is settling in front of the lens. Now, if you get a cold weather, I know it's only a few of you out. It's only the not doesn't affect every airport, but for many airports, you get cold weather on top of the precipitation, and then that turns to ice, and there's nothing to melt that ice. So it really is a problem, and I've had this reported by airports. And again, I know you can put heater systems in these lights, but the airports, but typically, I very rarely see heater systems installed on LED lighting. So this is a matter for regulators and airports, because the consequences are potentially very, very dangerous. You also get in circumstances of when you have the glass is colder than the air at night, you get very heavy condensation on the lights. I had to go and retest a runway recently where during last winter, where following rectification works, a retest was required, only to discover the runway in question was non-compliant. And why was that? Well, the lights had all been cleaned that day. And we're not talking about 100%, we're talking about 50%. I went out and looked at those lights, and they all had heavy condensation on the lenses, and these were elevated edge lights, completely non-compliant. We had to go and wipe every single lens and then test them quickly, because the condensation comes back in those conditions. But I mean, that's almost cheating. But I'm trying to measure the lights, but what do? The lights, when they're covered in this condensation, do not meet the photometric requirements. So again, a plea to the people that design the lights there. We need to do something about this, and regulators need to understand this potential issue. It's not good enough just to test lights in perfect conditions just after they've been cleaned and declare them serviceable. They need to be working in the harsh conditions for which they're designed for, when the pilots most need them.
The most difficult lighting, the inset lights on the runway, most difficult ones to design and maintain, because you're explaining the water accumulates in front of the lenses and so on. The basic design guidelines for those were set down in the 1940s, early 1950s. And one of the thing that, of course, determines how deep that trough is the maximum height of the fitting you're allowed to put on the runway. With modern technologies, I wonder whether that one can use less vertical space, as it were, to provide the light. That's one thought. But the main thing is that the specification for the height of the light goes back to say to the 1950s, when there were quite a lot, bearing in mind the lighting is used as much by military as by civil, as far as the manufacturers are concerned. The pressure came from the military, who had got at that time quite a lot of high performance aircraft that had very high tire pressures, so like 400 pounds per square inch. That they were extremely high pressure tires, and the danger of them being damaged and having a tire blow was very, very, very concerning. And that's why the heights that are specified today, that's where they came from. I beg to ask the question today, is this relevant, perhaps to the military, but to the civil world with modern undercarriage design and tyre design? Are we still providing something that isn't actually needed? Could we have fittings? Could we have fittings that could not be other than flush with the runway? In other words, not buried in the tarmac. And secondly, I would say, from my experience of the military as well with the Navy, where they have lights in the deck, and when you've got aircraft with arrestor hooks, you can see if you've got a hook dragging along the surface, that can awfully damage the light. Well, they effectively put around the light, they put a surface which is sloped, so the light is actually the hook is actually thrown up in the air, so it never contacts the actual light fitting. That probably isn't directly relatable to civil aviation, but you see what I'm saying? There are other ways of looking at it, and what the basic designs that people are using and the basic thoughts behind them are about 70 years old. I think it's time somebody had a really good look at inset lighting and how it could be achieved today, and obviate some of these issues you're raising, Robert.
Yeah, thank you, Tony. It just brings to mind, I was recently at an airfield in the United States, and the lights were installed so the top of the fixture was flush with the runway surface itself. These were LED lights, and I was told that that is what the airport had requested. So I was quite surprised by this, because these lights had just gone through a winter where they had pooled and ice had formed in there, completely obscuring the light output. So in writing the report, and this is something we've all heard, I went on to AI because I wanted a shortcut to find the relevant regulation, and I Googled and I put the question in: what is the regulation relating to the maximum, to the height of the installation height of the fixture, according to FAA regulations? And AI came back and told me that the top of the light should be flush with the surface of the runway, which is exactly what I've been told the airport had requested. Now, this result of this was lights that were pooling water, because they were almost, some of them were almost half an inch the length, but they're between the top of the fixture and the runway surface. The AI was actually wrong. Because I couldn't believe this, because it was such nonsense. I actually went through the FAA documentation, and I found the relevant section, which talked, I think, the maximum for the light fixture, edge of the light fixture below the surface of the runway is 1/16 of an inch. The maximum, and even that's probably too much given the negative slope in front of the lens. But these lights are well below the surface. So be very careful, as we've all been told, be very careful with AI. But of course the aim here was to try and minimize the the top of the light fixture protruding above the level of the surface, because it's perceived negatively by pilots. But of course, if that makes the light ineffective, then that I'd say is a far more serious problem. So we have time for one more question.
Yeah. What about Annex 19 as a mandatory requirement for a safety management system? Hence, Annex 14 and supporting documents are not the only references regarding personal competency and compliance to standards and recommended practices. Please explain. Yeah, at the end of the day, if you go through 9137, 9157, you go through the ADRs, you go through the EASA ADRs, you go through the ADRs with CAP 139 as it used to be. There are recommendations and details of the requirements for personnel in many, many documents. One of the problems we have as a training organisation, and I don't normally get into what we actually do on these things, but one of the problems we have is actually establishing what the training requirements are within the regulatory requirements, because they are scattered so far amongst the different documents. And there is a lot of groundwork that needs to be done when you're doing things. The other thing about it is it's a double-edged sword. It's a two-way sword. The airport has a responsibility to its personnel to ensure that the persons carrying out the training are suitably qualified as both trainers and with regard to the profession or skills which they are training in. And as such, the airport should maintain a record of all personnel who are involved on training their people. That actually also is something that comes under the compliance requirements, is that the airport manager is responsible for ensuring that those records are maintained by the airport. So it's a double-edged sword. We as trainers have got a lot to do to make sure that we are providing the right training, and the airports have also got to make sure that they are employing the right trainers to provide the correct training.
Thank you, Tony. And this is a question to all of you here, so pay attention, I may pick on you. What is your opinion on proactive maintenance? Majority of airport maintenance I've seen are primarily reactive. I believe this is due to a high operational tempo and limited maintenance windows. So I think Seward's joined us. We're seeing this in particular in relation to some discussions we're having on the maintenance advisory circular from the FAA. 150534026C. What's your view on proactive versus reactive maintenance?
My view is simple, like you just indicated. It's mostly reactive and not proactive. And the job we have is to try to make it proactive, and we've been trying to do that for years.
And I think this is the work that's been done on this particular advisory circular is aiming to achieve that, because it actually promotes reactive maintenance techniques, not proactive. Also, building on the substance of our webinar today and compliance, Tony's been talking about how we can maintain compliance with the ever increasing demands on our limited runway availability. Well, proactive maintenance is the obvious way. We have the data now, we have the measurements, we can use those to plan our maintenance, to optimize its effectiveness and its efficiency, so as we can get more done in less time, and we don't have to react to situations which could be avoided if we applied the correct tools, people correctly trained in an intelligent way to head off any of these circumstances or non-compliances occurring in the first place. A lot easier said than done, I can tell you, because we have, the demands are very high. But I'll leave you with that thought, and this is a topic we will be coming back to. We have the next webinar will be on Damon on Tuesday the 30th.
That's correct.
We're looking to return to our format of the next webinar will be a case study. from an airfield, looking at how they do maintenance. We have very positive feedback from the previous two we've done on that particular area. I know it's an area of great interest to you all. I'd like to thank our presenters today, Tony and Kev. Thank you for putting that very informative presentation together. And thank, of course, to our panelists here, Tony, Seward, Kev, Tony again. We look forward to seeing you all on the 30th of June. But thank you all for joining us. Cheerio.
Yes.
Cheers.
Thank you.